Hi, my name is Kent Lee and I teach computer science at Luther College. In this series of videos, I'll be talking about data structures and algorithms with Python, which goes along with the text that I've written with my co-author Steve Hubbard. I would highly encourage you to go out and get this textbook and read it along with watching these videos to get the most from these topics. Okay, so we're going to spend a little bit of time looking at the debugger here within Wing, and we're going to use it to understand a little bit about how object-oriented programming works. Last time I wrote a couple of magic methods. These are called magic methods that are a part of the ASCII class here. They're called automatically when we do things like, for example, print, because print is going to convert each variable into a string and therefore call the string method here, the string magic method. And when a list is printed, repr is called on each of the elements of the list. So this repr magic method is going to be called when the list is printed here in this part of the program. We're going to see that happen, but I'm actually going to write a couple more methods for this as well. I'm going to write a getOrd method, which has self as a parameter, which just returns the self.val, the ordinal value of the ASCII character. And I'm actually going to write a getChr, which is going to actually return the ASCII equivalent, or the character equivalent of this ASCII character. So this one's going to return chr of self.val. Those might be a couple of useful methods. I'm going to go ahead and call each of them down here on at least one of the objects. So we'll call x.getOrd and we'll call let's say z.getChr so we can see how that works. Okay, so let's go ahead and execute this code so we can see how it might work. That can be done through the debugger up here, and there is at this point there's step into, which is allowed. There is a run to current cursor position, which is allowed, and then there's just start debugging. You can set a breakpoint at any point within the code that you might want to. I think I'll go ahead and set a breakpoint here. So you just click in that gray bar over here and that sets a breakpoint. If I were to run this code, it will run up to the breakpoint and stop at that breakpoint. So I can stop it and see what's going on. Now the cool thing about this is that once I've stopped it, I can look at the stack data. And this shows me the runtime stack. The runtime stack is a stack of activation records where each activation record shows the local variables that are defined within that function that's being executed. We're inside the main function here, and you can see that x and y have been defined so far. When I set a breakpoint, I have not executed this line of code yet. It stops before executing that line of code. So far I've defined x and y, and I'm about to define z. So I'd like to step into this to see exactly how this works, how this code is going to be executed. And if I go up here, I can click step into and I can watch exactly what happens. Now you notice I jumped from here up to here, and I said before this is the constructor for this class, and it's called as soon as Python has created the object. So within this activation record now, and I want to make sure you understand, there are 3 activation records on the runtime stack. One is for the module, which in our case doesn't really have anything in it. We could go back and look. These are the things that are defined within the module, but they're all defined by Python, nothing that we've defined directly. We are in main, just about ready to execute. We're starting now the execution of this statement here, and the furthest point that we've gotten to The deepest point that we've gotten to is the constructor right here. So Python has created the object. This is the object right here. So we're able to look at that and see what's going on there. If I were to look inside of the object, these things are all defined inside the object by Python. We don't have to do that ourselves. And you can see the we can see that there's a bunch of different information in there. We're about to add val into this object, so we're going to see val added here in just a moment. I'm just going to do a step over so you can see that step over is another thing that you can do. And once I've stepped over that and look down here, there's val right there, and it's equal to 10. So that's in the object. Self.val, that's in the object. It's in the object that will be referred to by z eventually. Okay. All right. Now you can kind of see that's underlined here. That means that we've executed that statement, but we haven't returned yet from this function, and we're about to return from it. So if I click step over one more time, I'm actually going to return from it, which I just did, and I'm on to the next statement after it, the print x here. So now we can look at all three and see what's inside of them. So x's val is 97. This is why we have self in the init, because we have three different objects that we're dealing with. The y's val is 3, and the z's val, if I open up z there, we saw was the 10 that we had there before. So each of these objects has their own val fields defined within them. We executed this constructor 3 times. 2 of the times we skipped, but the third time we watched it actually execute. So if I step into the print here, we'll see what's going to happen. To print x, we're going to want to convert x to a string, really what x refers to a string. And because there is a string magic method, we're going to end up in that. So I'm going to step into it here so I can watch exactly what happens, and sure enough, I end up right in the string method here. So print called string first to convert x to a string. So I can step over it and watch what happens. It turns out that it's between 33 and 126 here. So I'm going to get in here and do the return. And just like before, I'm ready to do the return right now. Come back. X has been printed using the string, and I'm printing the A there to the screen. Okay, so I can do the same thing again for Y. I could go ahead and set a breakpoint in here so that I could watch what's happening, and I can just click the play button and it will take me right into there and stop right there before it executes. Again, step over is going to let me watch what's going on here, and I'm about to return the period for it. So I could click step over. I can also do step out of, which means it's going to do the return for me and stop right after it is returned from this function. So right after returning from print y, it'll be the print z that gets executed next. I can go ahead and turn off this breakpoint. I could do a step into just to demonstrate how these things work, and I'm back in this string function even without the breakpoint, so long as I do a step into. Step over again, let me see what's going on. I can do a step over, I get the underline, that means it's about ready to return. So I'm back here and I've printed the 2 periods now. Okay, so in building this list, if I go and I want to see exactly what's going to happen here, or I'm sorry, instead of for printing this list, if I click step into, you're going to see that I get in here, and self, if I look at self here, self is this reference that's got 0x1022-4AB00 as a part of it. Now if I were to back up one activation record back to main, I see 1022, let's see here, 4AB00, that's the reference for X. So X is the thing that I am calling string on right now, if I go back to repr, you can see I've got the exact same reference right here as for x. So self is the reference that's pointing to the same thing that x points to. So we saw this in a picture in an earlier video. Both references point at the same object. Self inside of this function, which is where we're stopped right now, inside of the repr function, but within the main function, x is the reference that points at it. So we're about to convert x to its representation. It's repr. I'm just going to do step out of here. We're doing it again for a new one now. So this is the second time. This is the y. I do a step out of. And there's the third one for the z. The z is the one that ends in 68. If I go back and take a look here, z is the reference that ends in 68. Okay. So click step out of one more time, and I'm ready to come back. I click step over there, click step out of, come back, and I've printed the 3 ASCII values there. Okay, so I do want to make sure that you understand exactly how methods are normally called. The magic methods got called automatically by trying to do the prints, but here I'm actually calling, directly calling, explicitly calling the getOrg method by writing x.getOrg. Now if I take a look at x is the one that ends, the reference that ends in 00, 0. So when I do a step into, again, self is going to be that same reference that ends in 00, 0. So when I write x.getOrg, I don't provide a parameter inside the parentheses, but I'm really providing the parameter right here. That's the parameter self that I end up with in getOrg. So I'm going to return self.val here, meaning x's val that I'm going to return. So when I return from this, you can see that 97 is printed, and that is x's value that we created x with up here. So same thing with getChr here. If I step into that, I'm going to see that self is 20 at the end, and that is exactly the same reference that let's see here, in getChr, self is 68 at the end, and that is exactly the same value that I have in my main for z. Z's reference is the one that ends in 68. So I'm calling getChr on z, and when I'm in the chr function, then executing this code and returning self.val, I'm returning I'm returning the chr of z's val. Okay. So I step out of it there, and it's going to print an extra blank line. I'm ready to return from main at this point. If I look at the runtime stack, I've got main and module. If I click step over one more time, I'm going to be back just at the module level. I'm ready to return from the module at this point because I only called main. So if I click step over one more time, execution is done. Okay, so I've shown you how to use the debugger. I've shown you how methods are called on objects. I've shown you how to create a class and create objects of its type. I've shown you magic methods and how magic methods get called. There are a number of magic methods that are available, many more than I've shown you here. Tried to indicate that before as well. One of the things I think you need to know is how to use this debugger to look for problems in your code. None of us write code perfectly the first time, so you will undoubtedly make mistakes like I do, and we need to be able to use a debugger to trace back to where that error occurred and figure out what's going on. With this picture in your head, this picture of what's going on, the runtime stack, the references that we have here, the debugger where we can look at the values of variables, we should be able to figure out what's going on in our program even when it doesn't make sense to us, so that we can figure out what our misunderstanding was and correct that in our code. Okay, that's enough for this one, and we'll continue on from here next time.